Welcome dear friends to one more session of chapter number 1, chemical reactions and equations. So last video we have discussed combination reaction. So today we are discussing the next heading, decomposition reaction. So what do you mean by a decomposition reaction? So the word that suggests to the reaction, decomposition, that means breaking down. That means we can say that a single reactant break down to form two or more products. That sort of reaction we call it as decomposition reaction. Decomposition reaction means a single reactant break down to form two or more products. That type of reaction we are calling a decomposition reaction. So the general representation of a decomposition reaction is a single reactant that is breaking down to form simpler substances or two or more products are forming. This is the general representation of a decomposition reaction. So the many equations are getting. Identify the decomposition reaction means the reactant side only one substance and the product side that means more than one substances, so that we can call it as a decomposition reaction. So this is A is the reactant and B and C, these are the products. So the decomposition reactions that is happening only if some sort of energy is absorbed, that is in the form of heat, light or electricity. The energy is absorbed, then only a compound will breaking down or decompose. So we can say that three different types of decomposition reaction. A decomposition reaction means it is an endothermic reaction. Endothermic reaction means during the reaction energy is absorbed, that we call it as endothermic reaction. That means decomposition reaction involves the breaking of bonds, so that require energy. So decomposition reactions are endothermic reactions. Already we have mentioned in the previous video, combination reaction. Most of the combination reactions are exothermic, but decomposition reactions are endothermic reaction because it involves the breaking of bonds. In the case of reactant, that means the breaking of bonds it involves, so that requires some sort of energy. So decomposition reactions are endothermic reaction. So three different types of decomposition. A compound is decomposing by the absorption of heat energy. We call it as thermal decomposition reaction. So decomposition reactions, first one we are going to discuss, it is thermal decomposition reaction. Thermal decomposition reaction. Then thermal decomposition reaction means a compound is breaking down by the absorption of heat energy. Thermal means that means heat. Heat energy is absorbing and the compound is decomposing. We can call it as thermal decomposition reaction. Then another set of decomposition reaction. A compound is decomposing by the absorption of light energy. We call it as photo decomposition reaction. Then one more type we have to discuss, that means a compound is decomposing by passing electricity through the aqueous solution, or the compound is in molten state. We are passing electricity through the compound and breaking down of that compound. That means that decomposition we call it as electrolytic decomposition reaction, or that means electrolytic decomposition reaction. So this is the objective today. So one by one, thermal decomposition, photo decomposition, electrolytic decomposition reaction we are going to discuss. So the first heading, thermal decomposition reaction. Decomposition reaction, first one, thermal decomposition reaction. So what in by thermal decomposition reaction? A compound is breaking down by the absorption of heat energy. So two examples are there in your NCERT textbook. First one, the example 1, Thermal decomposition of lead nitrate. Thermal decomposition of lead nitrate. So we know lead nitrate, the formula it is PbNO3 twice lead nitrate. The decomposition of lead nitrate. So what we have to do in a test tube, take some powder, that means lead nitrate. So lead nitrate, white color crystals that is available in the laboratory, lead nitrate. So take powdered lead nitrate in a test tube and heat it over a flame. So thermal decomposition of lead nitrate. So take powdered lead nitrate in a test tube and heat it over a flame. So what's observation? During heating you can see that that means brown fumes are evolving from the same. From the test tube you can see that brown color fumes are evolving. Brown color fumes are evolving. Along with that means one more gas is there. So near the test tube you are bringing a glowing splinter, means that will catch fire. So that means that produces flame here. So brown fumes are producing and showing one glowing splinter here means it produces flame there. That means the same compound that break down to form three products. So lead nitrate is heating, thermal decomposition reaction. So heat is absorbed and it break down to form three substances. So during the reaction you can see that brown fumes are evolving and one more gas is there that that means burns a glowing splinter, and one residue will be there after the reaction, that is lead oxide. So an yellow color residue will be remaining at the bottom of the test tube, that is lead oxide. So lead nitrate decomposes to form three substances, lead oxide plus brown fumes means it is nitrogen dioxide, along with that means a gas that burns or that means produces flame on a glowing splinter means it is oxygen. So lead nitrate decomposes by the absorption of heat energy that produces three substances, lead oxide. As a residue will be there after the reaction, a residue will be there in the test tube, that is lead oxide. Residue means something left after the reaction, that we call it as residue. So lead oxide and brown fumes, that is nitrogen dioxide, along with one more gas is there that produces flame on a glowing splinter means it is oxygen. So these are the decompositions. That means a single reactant here break down to form three products. So the salt color, everything you keep in your mind. White color salt, lead nitrate, lead oxide, the residue color it is yellow, and nitrogen dioxide means brown fumes are evolving from the test tube. Then after the same you have to write the balanced chemical equation for the same. So how to balance it? Biggest formula here, how many oxygen? It is 6. That means 3 into 2, it is 6. Right side how many? 2 plus 2, 4, 4 plus 1, 5. To make it 6 means 2 here, 2 lead. So you can put 1, 2 here. The number of nitrogen automatically it is 2 into 2, 4. So 1, 4 here. So this is the example 1 thermal decomposition reaction of lead nitrate. One more example that is in your NCERT textbook. Thermal decomposition reaction of ferrous sulfate. Thermal decomposition of ferrous sulfate. So ferrous sulfate crystals having the formula FeSO4.7H2O, having the color it is light green. Light green. So the decomposition of ferrous sulfate crystals, read it as FeSO4.7H2O, ferrous sulfate heptahydrate. The 7th H2O stands for water of crystallization. That means during the formation of crystals, these amount of some water molecules are trapped inside the crystals. that we call it as water of crystallization. Water of crystallization means it's a fixed number of water molecules associated with one formula unit of a salt. A fixed number of water molecules associated with one formula unit of a salt, we call it as water of crystallization. So 7H2O stands for water of crystallization. This is the amount of water that is trapped inside the crystal only. So ferrous sulfate heptahydrate, having the color it is light green. So the light green color crystals you take in a test tube. Ferrous sulfate crystals having the color it is FeSO4.7H2O. Heat it over a flame. This one you heat it over a flame. And what's observation? So on strong heating you can see, first you can observe, that means some water droplets on the sides of the test tube. First you can observe some water droplets on the sides of the test tube. That means on heating ferrous sulfate it loses its water of crystallization. So first step means FeSO4.7H2O loses that water of crystallization and it turns FeSO4 alone plus 7H2O. So this one we call it as anhydrous ferrous sulfate. This is the word. It is in a compound, from a compound water of crystallization is removed, that we call it as anhydrous. The word it is anhydrous ferrous sulfate. The water of crystallization is removed, we call it as anhydrous salt. So on strong heating, first you can see some water droplets on the sides of the test tube. That means water of crystallization is removed from the test tube. Then again further heating, that compound FeSO4 decomposes. So FeSO4 decomposes on this. So this is the decomposition reaction. Anhydrous ferrous sulfate, on it again strong heating it decomposes to form. After the reaction you can see that a reddish brown deposit at the bottom, that is the residue. So a reddish brown color substance at the bottom and some gases are evolving from the same, having the smell of burning sulfur. So reddish brown deposit at the bottom means it is Fe2O3 ferric oxide, and some gases are expelling from the same, having the smell of burning sulfur. So the evolving gases are sulfur dioxide and sulfur trioxide. So the compound, a single compound, break down to form three products. That means ferrous sulfate turns to ferric oxide. Reddish brown substance at the bottom means it is ferric oxide. This is ferric because valency of iron here it is +3. That means the valency is 3 iron. The charge it is +3, valency is 3. So this is ferric oxide along with oxides of sulfur. That means sulfur, this is sulfur dioxide and this is sulfur trioxide. So the gases having the smell of burning sulfur. And when we are bringing a wet blue litmus paper near these gases, the gases are evolving from the test tube. These gases are evolving from the test tube. That moment you are bringing a wet blue litmus paper here means these gases turns wet blue litmus paper to red. Why? Means these are non-metal oxide. That means we can say that means these gases having the character acidic nature. The gases having the character acidic character, that turns blue litmus paper to red. Then this is the substance ferric oxide, having the color it is reddish brown. Reddish brown. So this is the thermal decomposition reaction of ferrous sulfate. Ferrous sulfate crystals on strong heating that decomposes to form ferric oxide and sulfur dioxide and sulfur trioxide. So two examples for the same thermal decomposition. A decomposition reaction that is happening by the absorption of heat energy. Then second type of decomposition reaction, that we call it as photo decomposition reaction. So second type of decomposition reaction, B, photo decomposition reaction. So what in by photo decomposition? Photo, the word stands for light. That means a compound is decomposing or breaking down by the absorption of sunlight, or that means light energy. So that means we can say that a compound is decomposing by the absorption of light energy. We call it as photo-decomposition reaction. So two examples means you take some amount, a pinch of silver chloride. So silver chloride salt means white colored salt. So silver chloride, take a pinch of silver chloride on in a watch glass and keep it in the sunlight for some time. You keep the salt in sunlight. So after some time you can observe that. So you have to write silver chloride. This is silver chloride having the color, it is white. White color salt, silver chloride, and keep it in sunlight. So after some time you can see that the white color salt that turns to gray in color. That means the compound by the absorption of sunlight and the compound is decomposed to form silver and chlorine. That means chlorine gas is expelled from the same. So silver having the color, gray we can write. So white colored salt turns to gray. So balanced equation for the 2 chlorine here. So 2 here and 2 here. Then example, one more example. We can say same way silver bromide. Take pinch of silver bromide and keep take silver bromide in a watch glass and keep it in sunlight for some time. Then so about the aroma, sunlight, the color it is yellow. Keep this color in your mind. Silver bromide having the color it is yellow. Keep it in the sunlight for some time. Then later it turns to gray in color because it decomposes to form silver and bromine. Silver and bromine. So the silver having the color it is gray. Silver having the color it is gray. And here one question, that means these reactions earlier times we have used in black and white photography. Photographic films are coated with these materials. So this is photo decomposition reaction. Then one more decomposition reaction, a single reactant that absorbs electricity and breaking down, that we call it as electrolytic decomposition reaction. So next one it is third one, electrolytic decomposition reaction. So electrolytic decomposition reaction means a compound is decomposing when electricity is passed through the compound in molten state or in aqueous solution. So that decomposition reaction we call it as electrolytic decomposition reaction. So the example we are discussing, it is electrolysis of water. That means the water is decomposing to form hydrogen and oxygen gas. Electrolysis of water. Electrolysis of water, the example. So having this experiment. So we can conduct an experiment for the same electrolysis of water. So how to conduct the electrolysis of water, the experiment? Electrolysis of water. Take a plastic mug. The experiment is this one. Take a plastic mug. Make 2 holes at the base. Make 2 holes at the base. And this base, that means these holes you fit it with rubber stoppers. Fix 2 rubber stoppers here. In these holes, fix 2 rubber stoppers. And through this rubber stoppers, you fix carbon electrodes. So, through this rubber stoppers, fix carbon electrodes. Carbon electrodes. And this carbon electrodes, that is connected to a this is connected to a switch, and it is connected to a 6-volt battery, 6-volt power supply or 6-volt battery. So take a plastic mug. This is 2 rubber stoppers. fixed to rubber stoppers and 2 carbon electrodes. And the next step, over this carbon electrodes, invert 2 graduated test tubes. 2 graduated test tubes, fill it with water. That means graduated test tube means test tube having the measurement. So invert 2 graduated, these test tube, fill it with water, and then invert this graduated test tube over these electrodes. Over these electrodes. Invert 2 graduated test tubes over this electrode. So then after the same, nearly half of this capacity, this take water inside this. Take water inside the beaker. Inside the beaker, nearly half of its capacity, take some amount of, take water. Then add some drops of sulfuric acid too. Why? Because water is a poor conductor of electricity. To increase the conductivity, add some amount of dilute sulfuric acid too. Then now switch on the battery and allow to run it for sufficient time. Then you can observe that when switch on current, then you can observe that bubbles of gases starts rising near the electrodes. Bubbles of gases starts rising near the electrodes, and the level of water in the test tube, it is falling down. So the positive electrode here we call it as anode, and negative electrode. So positive electrode we call it as anode, and negative electrode we call it as cathode. So we can see that on passing electricity, that means the level of water in the test tube, that is getting down, and amount of gas bubbles are started rising near the test tube. So you can see that in the test tube covering the cathode, the amount of water level getting decreased, that is double than that of the other. So here gases are collected on the top of the test tube. So you can see that the amount of gases collected in test tube covering the cathode, it is double than that of the other. That means we know water, inside this water it is taken. Water means H plus and O2 minus. That means H2O means the ions are H plus and O2 minus. Positive ion will move towards the negative electrode, and the negative ion, oxide ion, will move towards the positive electrode. So the gas collected in the cathode, it is hydrogen. So the gas collected in the cathode, it is hydrogen, and gas collected in the anode, it is oxygen. So why this is the amount of water level, it is getting decreased in the test tube. The amount of water level, it is getting decreased, and the amount of gas collected, it is double in one test tube. Why? Because we know in H2O, the hydrogen and oxygen is in the ratio 2:1. So this is another question, why it is one test tube, it is double than that of the other. Because in H2O, the hydrogen and oxygen is in the ratio 2:1. So the gas collected in cathode, it is double, it is hydrogen, and this one it is oxygen. Then if you want to test these gases, take out this test tube and test these two gases. So bringing a glowing splinter means this oxygen produces flame there. So glowing splinter there, it produces flame, means the gas, it is oxygen, and the gas, that means the gas burns with a pop sound, means it is hydrogen. Such a way we can test these two gases. That means here H2O is decomposed on passing electricity. On passing electricity, H2O, that is decomposed to form hydrogen gas and oxygen gas. So balanced equation for the same on passing electricity. So this is an example for electrolytic decomposition reaction. So Decomposition, generally decomposition reaction means a compound, a single reactant break down to form two or more products by the absorption of some sort of energy. So three types of decomposition reaction: thermal decomposition reaction, photo decomposition, and electrolytic decomposition. So I hope you understood the same. If you like it, you please subscribe the channel. So the remaining portions, next videos we will discuss. So thank you for watching the same.